Okay, right now I'm just going to give you a quick kind of overview of key problems from the 4 sections for tomorrow's test. So probably the best way to go about this would be to pause me now, try the problem, and then restart it and see if you came up with the same answer. So if we're going to solve by graphing, remember we are looking for that one ordered pair, that xy, that makes both equations true. So the first thing is we need to get into the y equals mx plus b form to graph. So I'm going to start with this one. I'm going to solve for y. So I'm going to have 3y is equal to negative x plus 18 divide by 3, y equals negative 1/3 x plus 6. That means my y-intercept is 6. My slope is negative 1/3, so I go down 1, right 3, or up 1, left 3. And this is an equality, and so I have a line that goes through about like so. And I'm going to go ahead and I'm going to do the same process for this one. So I'm going to have 2y is equal to x plus 7 when I add x to both sides. Y is 1/2 x plus 7/2. So right now I know my lines are not parallel, so I know I will have a solution somewhere. So 7/2 is really 3.5, about right there. And it's a positive slope, so I go up 1, right 2, up 1, right 2, and so my line cuts across about like yay. And so my solution, my answer, and this is the part that you need, is you have to write that your solution is 3, 5, because I need to know that you know that is the ordered pair that if I put it in makes both equations true. This is a similar problem out of 3-1. We're going to graph and we're going to describe the systems as consistent and independent, one solution. Consistent and dependent, that's infinite solutions because it's the same line. And inconsistent is no solution because the lines are parallel. So we're going to go ahead and get these into graphing form first. So I'm going to do this one first. So I have 3y is equal to negative 2x plus 5. Divide by 3. Y equals negative 2/3 x plus 5/3. Then I'm going to go ahead and I'm going to graph this one. Solve for y. Negative 9y is equal to positive 6x minus 15. Divide by negative 9, y equals negative 6/9 x plus 15/9. Those two fractions reduce. Y is equal to 2/3, negative 2/3 x plus 5/3. And when I look at that, this right here and this right here, those are the exact same lines. So without even graphing, unless my directions ask me to, these are the same line. Therefore, infinite solutions, which means consistent and dependent. So I can tell all that by looking. Now in 3-2, we did our other two methods of solving, which are by substitution and elimination. So remember, substitution, we're replacing. This one happens to be solved for x, and so I'm going to treat that like a single number, and I'm going to replace right there. And so I'm going to have 5 times 4y minus 10 plus 3y equals negative 4. If one of the equations is not solved for a variable, you need to go ahead and use your algebra and do that. And so distributive property, 20y minus 50 plus 3y equals negative 4. Combine like terms, 23y minus 50 equals negative 4. Add 50, 23y is equal to positive 46. Y is 2. That's your first answer. Then you take that answer and go back to one of your originals. X is equal to 4 times 2 minus 10. So x is equal to 8 minus 10. X equals negative 2. And so our ordered pair where these are true, if we were to graph them, are at 2, -2. So that is how substitution works. Now, elimination. Elimination is just like it sounds. We want to eliminate or get rid of one of the variables. And we do that by multiplying one or both of the variables by a value so that when we add them together, one of the variables drops out. So I always look for opposite signs to start with. And so here I see the q's are opposite signs. So 4q and 8q both go into 8. So I'm going to multiply top and bottom by 2. So this top one is going to stay the same. And the bottom one becomes -50. That. Now when I add them together, this will become 0, so it is eliminated. And so I have 16p is equal to -32. P is -2. That's my first answer. Take that and substitute in, and so I have 6 times -2 plus 8q is equal to 20. So I have -12 plus 8q equals 20. Add 12, 8q equals 32, q equals 4. And when you're making ordered pairs for letters that are not x and y, you always go in alphabetical order. And so my ordered pair is -2, 4. Now when we go on to 3, we're still solving systems, but now we're solving systems of inequalities. And so this is where we get into the shading. So y is less than 3 is a horizontal line that's dashed that goes through right here. Where are the y's less than 3? They're less than 3 in this direction. That's this one. Now this one, I have to solve for y. So I have y is greater than or equal to x minus 1. I'm going to add x. I do not have to flip. I just add x to both sides. So my y-intercept is -1. My slope is +1 over 1. And I have less than or equal to, so I have a solid line that cuts through like this. So now I have to figure out where to shade. So I'm going to test with 0, 0. Is 0 minus 0, is that greater than or equal to -1? 0 is greater than -1. So I'm going to shade the side that includes 0, 0. And so the solution region that I darken and make clear is where they overlap. So that graph right there is my answer. Number 2 here, same sort of thing. These are both solved already for y, so I can go ahead and just graph them. So the first one has a y-intercept of 5, has a slope of +1/3, so I can go up 1, right 3, down 1, left 3, dashed line. If I test with 0, 0, is 0 less than 1/3 times 0 plus 5? Is 0 less than 5? That's true. That's my test point. So I'm going to shade everything that includes my test point. Then I'm going to go ahead and I'm going to graph this one, which has a y-intercept of 1. It has a slope of +2 over 1, so I go up 2, right 1, up 2, right 1. It is also a dashed line. And again, I'm going to test with my 0, 0 point. Is 0 greater than 2 times 0 plus 1? Is 0 greater than 1? That's false. So I shade the side opposite 0, 0. And so again, my dashed boundary where they overlap and a dashed boundary where they overlap. And I darken this area in right here. Now, a third example that we can ask in this situation is find the vertices formed by the system. So you go ahead and you graph your inequalities just like you would. This one is in slope-intercept form. 7/3 is 2 1/3, so just over 2. And I'm going to go up 1, right 1, 2, 3, or I'm going to go down 1, left 1, 2, 3, and this is a solid line that's going to cut through like this. Now I'm going to go to the next one. This one I need to manipulate first, so I have negative y is less than or equal to negative 4x plus 5. I need to flip the signs. I need to multiply by a negative, so don't forget to flip. Y is greater than or equal to 4x minus 5. So minus 5 is my intercept. My slope goes up 4. 1, 2, 3, 4, right 1. And this is also a solid line, and so I have that region right there. My last equation is already solved in slope-intercept form for me. The y-intercept is 1/2. It has a slope of negative 3 over 2. So I go down 3, 1, 2, 3, right 1, 2. This is also a solid line. And so the vertices that we are after are those right there. And so my vertices are 2, 3, negative 1, 2, and 1, negative 1. I could have done the shading, and what would have happened is I would have ended up with this region being shaded also, so that is also a nice little touch. Now our last set of examples, we're going to go through and do the graphing in the same way, and then we're going to find the max and the min. So I'm going to go ahead and pause it in the graphing to save time for the video, because you should be getting pretty proficient with that. So once I have graphed and shaded, it's clear that I have this bounded region right here where everything overlaps, and my vertices for that are at 0, 2, 5, 4, and 5, 2. So I'm going to have to go ahead and test these into this function right here to find out my max and my min. And so I make a table of my x, y values, those vertices, and then I'm going to find out what my function value is. So if I put 0, 2 in, if I put 5, 4 in, and I put 5, 2 in, I'm going to have 3 times 0 plus 2 equals 2. And I'm going to have 3 times 5 plus 4, which is 19. And I'm going to have 3 times 5 plus 2, which is 17. So obviously 2 is my min, and that is at 0, 2, and 19 is my max at 5, 4. I'm going to go ahead and do the last video on, or the last example on a separate video.